I've separated potential objectives for using text functions into two categories. The first one relates to when you are trying to extract or manipulate text. If you want to snag the first or last characters in a string of text, you can use the left or right functions. You first reference the text you want to pull data from, and then you indicate the number of characters you want it to retrieve. It will respectively pull data from the left or right-hand side based on which function you use. You can also combine strings together using the concat function. This is short for concatenate, which is the name of the original function that did this task. Microsoft had been slowly discontinuing it. Concat is what we use today. Like many functions, you can reference either cell values or hard code in text to combine strings into a single value. I've also added a few functions that relate to formatting text. Trim gets rid of extra spaces in a text, leaving only one single space between words. You can also mess with the capitalization of text using upper, lower, and proper. The first two will convert all characters to either upper or lowercase, whereas proper capitalizes the first letter of each word in a string. You can imagine this is probably going to be helpful with names or any other proper nouns you might be working with. And I think this is getting kind of old, but if you remember those SpongeBob mocking memes, these functions would help smooth out the capitalization employed in those. We have two basic tasks in our first exercise. We have a list of employees that work at our company, and the first thing we want to do is take these name values that they've typed in themselves and combine them into a nicely formatted single entry. As you can see, there's a lot of inconsistency in the way they've typed these in, but ultimately we want this to be formatted as last name, comma, first name, in proper case. In other words, we only want the first letter of each word to be capitalized. I'm going to start by writing the formula to just combine them. The function to do this is concat. We want to specify the last name first, so my first text will come as a reference to cell C4, comma. Next, I want to include a comma and a space to separate the last and first names. To manually hard code in some text, like usual in Excel, we have to put it in quotes. So for my second text, I type open quote, comma, space, and close quotes. By putting that comma within the quotes, this lets Excel know not to proceed to the next parameter within a given function. But now that we've closed these quotes, I'm going to hit comma again to proceed to the last string of text we want to include here. We'll make a reference to cell B4 and hit enter. Okay, so this has given us the string of text we want, but we still need to incorporate the desired formatting. To do this, I'll click this cell, and then at the start of its formula, in the formula bar above, I'm actually going to start it with the proper function. Proper, open parenthesis. Essentially, we've now nested our original concat function within this proper one. But if I don't add an additional close parenthesis at the end, Excel's going to shout at us. See, watch this. Now, fortunately, this was an error where Excel was able to just suggest adding a closed parenthesis at the end. But you won't always be so lucky, so be careful with how you start and end your functions. Yeah, we'll accept this correction. And there we go. Now it's all formatted correctly. Our second task is to make an extension directory for these employees' office phones. We have their full phone number here, but if we're calling within the company, we can just dial their 4-digit extension, which is the last 4 digits of their phone number. This will be pretty simple. I invoke the write function, select the text I want, which in this case is the phone number field, comma, and the number of characters I want, 4. I want the last 4 digits. Very good. Done. Now I want to show you a pretty neat forensic accounting application of when you want to be able to extract the beginning of a string. And this relates to your reading on Benford's Law. Now, this isn't actually a law of nature, but Benford's Law relates to how the leading digits of numeric datasets are often distributed. As you read, it's important that these be naturally occurring numeric variables, where there is no upper or lower bound to the values these numbers can take on. So if you've got a sufficiently large set of data, and the values the numbers can take on crosses multiple magnitude of orders, you might just have a data set that conforms to Benford's Law. There are a lot of examples where this applies, demographic data like populations, geographic data like river lengths and mountain heights, even things like Twitter followers, phone call lengths, street addresses. These all can conform to Benford's law. I don't need you to know the exact proportions for leading digits in this distribution, but very simply put, it predicts that 1 is going to be the most common leading digit, where approximately 30% of all leading digits will be 1s. The next most common digit will be 2, then 3, and so forth, until you get to 9, which would only constitute about 5% of leading digits. You can further refine this to what the first 2 digits of a number look like, but we'll keep things simple in this analysis and just use the single leading digit. Let's take a look at some real data, population estimates for all the counties in the United States as of 2023. We know that to snag the leading digit, we can use the left function. Specify the text, and we just want 1 character. So number of characters 1, and we'll copy this down. Now to actually see this distribution, let's practice our conditional functions. In this table on the right-hand side, we can use a countif function. We'll make an absolute reference to this range in column C. We'll select all of it, hit F4, and as criteria, we'll use these digits off to the left-hand side. I'll copy this through the 9th digit, and then I want to practice another Excel shortcut, the AutoSum shortcut. To quickly add up all those numbers, I'm going to push and hold the Alt key, followed by the equal sign. Alt equals is AutoSum. It automatically constructed a formula to sum up all those values in this proximate range. So I hit enter. I'll calculate each digit's proportion by dividing the count by the total. Of course, making an absolute reference to that total cell. And we'll drag this down. As you can see, with about 3,000 counties, roughly 30% of their populations start with the number 1, and just under 5% start with 9s. Let's make a quick graph in Excel to look at this. I'll highlight from digit all the way to the 9th count. I'll go up to the ribbon and select Insert, and I'll just use their first recommended chart. That looks good. I'm not trying to jump the gun with data visualization in this course, just doing a quick and dirty graph. And hopefully the shape of this distribution looks similar to what you saw in your reading. But you're probably not going to make it a habit of working with population data in the future. But as accountants, I imagine that you will be working with, financial data in the future. Dollar amounts of financial transactions, that's often another good application of Benford's law. So let's look at this second set of data. These are hypothetical purchase transactions at a company. We'll take the left digit of all of these. Left, here's my text. I just want the first character. And copy that down. Now you might be wondering, why isn't it picking up the dollar sign? That's a good question. Again, this just relates to number formatting. Only numbers are being stored in these cells, but since the format is set to accounting, it automatically presents a dollar sign at the front. To update my table over here, instead of reconstructing these formulas from scratch, I'm just going to click on the formula bar and change the range. I can move it over here, but that's not going to go all the way to the bottom. I'm going to get rid of this reference, and for my range, select from G3 down to the bottom, G10001. Absolute reference still. Although, I'll admit, with so many observations, even if you didn't make the absolute reference, you're probably going to be okay. Be sure to copy this down in our table to the right. And what do we notice? We've got significantly fewer leading 1s and significantly more 9s. This is a surprising result. But what if I told you that at this company, there is a policy stating that any purchase transaction above $10,000 requires a manager's review and approval? Well, in this case, there is an artificial, legitimate reason that the distribution is going to be affected in this way. You're probably going to have individuals motivated to make transactions that fall just under this $10,000 threshold. So this is an example where a deviation from Benford's law could be expected. Though internal audit might consider focusing their attention on the deviations. If fraudsters are making payments to fake suppliers, in other words themselves, they're probably aware of this threshold as well, and they could very likely be among these extra 9 observations. Let's try the last data set. This time, we'll put ourselves in the shoes of an external auditor. We're going to audit a company's various accounts receivable balances. So, repeating the process from before, left, we'll select this text, just the first character. We'll copy this down, and we'll update the table over here. Changing my range to K3 through K5002 absolute reference. And there is our distribution. Now, if you see a distribution of financial data like this, and if you are unaware of any reason that the data should depart from Benford's Law, this should raise some eyebrows. This wouldn't be the first time that external auditors are presented with completely fabricated data. And when humans fabricate data, they aren't always aware of all the statistical properties that should be reflected in their fraudulent numbers. So I don't want to oversell this particular application, but I do hope you found it interesting. In this exercise, we were able to use a basic text function and a COUNTIF to help direct an analysis, which is pretty cool.